These past few days, we have been solving systems of equations by using the graphing method. Today, we are going to focus on the algebraic method sometimes used to solve systems of equations. This method we're going to use today is the substitution method. And we're going to work through several different examples so you can get used to the process, the different steps involved that it takes to solve a system of equations by using the substitution method. We see here we have two systems of equations, 3x plus 6y equals 12 and 3x minus 6y equals 12. What you want to do when you use the substitution method is you want to solve one of these equations for either x equals or y equals. It doesn't really matter which one you solve for x or y, or what you solve for x or y. Just pick one and go with it. Now, as we go through different examples, hopefully you'll pick up on some cues that, oh, it'd be easier to solve this one for x or that one for y. So let's look at this first one. This first one I'm going to solve the second example for x. I'm going to do that by adding 6y to both sides. So we have 3x equals 6y plus 12. Then I'm going to divide everything by 3, just solve it out. So we get x equals 2y plus 4. What I do with that, that is my new manipulated around equation in the form of x equals. So we solved one of them for x equals. What we do with that is we take this x equals 2y plus 4, and we plug it in, we substitute it in to the other equation that we didn't work with. So this x equals, I'm going to substitute it into this top equation, 3x plus 6y equals 12. So we have 3. Substitute in this x, which is 2y plus 4 plus 6y equals 12. And what I do from here is I go ahead and solve it out, and I find out a number value for y. So I have to use my distribution. So I have 3 times 2y is 6y. 3 times 4 is 12. And then I have plus 6y equals 12. Keep combining your like terms. 6y and 6y is 12y. 12y plus 12 equals 12. Subtract 12 from both sides. So 12y equals 0. And then divide both sides by 12. So y equals 0. This, y equals 0, is only half your answer. You take that value. Again, you're going to use substitution. You're going to substitute it back in to your equation. I am going to substitute it into this x equals the equation that I solved for x. I'm going to go ahead and plug it in there for my y. So I have y equals 2 times 0 plus 4. X equals 0 plus 4. X equals 4. So there's the other half of your solution. Now the answer I want to see, the way that I want you to write your answer is I want you to write it as a coordinate. So your x is 4, your y is 0. 4, 0. Let's take a look at another example. This time we have 2x plus 3y equals 6 and 4x plus 6y equals 6. So let's see. This time let's go ahead and solve for whatever, it doesn't matter. Let's solve this bottom one. We want to solve it for x this time, or y this time. So this time we're going to subtract 4x from both sides. So we have 6y equals negative 4x plus 6. Divide everything by 6. So we get y equals, I'm going to go ahead and reduce my fraction to negative 2/3 x plus 1. So this time I wanted to show you what it looked like when you solve for y, the steps you're going to take. So we have y equals negative 2/3 x plus 1. You're going to substitute it in for your y in your other equation. So we have 2x plus 3 times this negative 2/3 x plus 1 equal to 6. So this used to be y, right here, and we just replaced it with the equation that we solved for to get in y terms of y. So now you use your distribution property, multiply that 3 out, so you have 2x plus negative 2x plus 3 equals 6. When we combine our terms this time, 2x plus a negative 2x, they cancel out. We get 0x. So we're left with 3 equals 6, which we know is impossible. That cannot happen. Those are not equal. So when this happens, you have parallel lines. Parallel lines will never intersect, therefore they have no solution. This happens when you substitute in your x's cancel out or your y's cancel out, and you're left with two numbers that are not equal. When that happens, no solution. No solution. Let's look at one more example here. This is one of those ones where you got to pick up on the cue. This one has a y that has nothing in front of it. It's already solved for y, so 1y. So in this case, it would be much easier to manipulate this bottom equation than trying to do the top one, where you'd have to add and then divide, or subtract and then divide. This case, you only have to add. So I'm going to add this 2x to both sides. And we get y equals 2x minus 5. So we have our equation in terms of y equals. Substitute it into the top. Always substitute it into the other equation you didn't work with. So in this case, we have 4x minus 2 times 2x minus 5 equals 10. Distribute. 4x minus 10, or actually plus 10, because a negative 2 times a negative 5 is a positive 10. So we have 4x minus 4x. These will cancel out. This time, we're left with two numbers, but they equal each other. If this happens, you have two lines with the exact same slope and also the exact same y-intercept. These lines are identical. They lie on top of one another. So they're going to have infinite solutions. Infinite solutions. So when that happens, your variables cancel out. You get two numbers that equal each other. Infinite solutions. So those are 3 examples of how to solve systems of equations using the substitution method.